Hello, hello, hello. 5.6 inequalities in one triangle. So we only have two sections in chapter 5. If you are one of those people who, when we went from chapter 4 to chapter 6, you're like, where did chapter 5 go? Well, here it is, but only two sections. So we're going to go over some theorems with triangles. So first we have the exterior angle, and we actually already know that this exterior angle right here is the sum of the two angles that do not touch it. So what we have here, when we're talking about inequalities is when we have greater than or less than. So because of that statement that we know that 2 plus 3, angle 2 plus angle 3 equals angle 1, that means angle 1 is always going to be greater than angle 3 and angle 2. That's always going to be the case. So if I look at this first question right here, it says, use this figure. Why is angle 2 greater than angle 3? I want you to pause the video and think that over first. A second. Well, first I have to look for where angle 2 is and where angle 3 is. If I look at this triangle right here, right there, I know that angle 1 right here is the exterior angle. So I know angle 1 is greater than angle 3, and angle 1 is greater than angle 4. Well, Mrs. Brigman, we're talking about angle 2. Well, we also see that this right here is indicating that we have an isosceles triangle. That means this angle is going to be congruent to this angle. So since these two are congruent, then I know that angle 2 is going to be greater than angle 3. So I'm going to write angle 1 is greater than angle 3 because of above. So, did you know that those three dots means therefore, or else you can say so, angle 2 is greater than angle 3. So I want you to look at problem number 2, pause the video, and try to do this one by yourself. So we have this angle, this angle. Those are the two that we're working with. If I look at angle 1 is greater than angle 3 because of the exterior angle theorem above, the inequality exterior angle theorem. I also know that angle 3 and 4, they're congruent because they're vertical angles. And since these are congruent, that means then I can replace angle 3 with angle 4. So therefore, angle 1 is greater than angle 4. Our next theorem that we have here is this is telling us xz. So this xz is greater than this xy. So it's saying that this length is greater than this length. When this happens, the angle across from it is greater than the angle across from this one. So because xz is greater than xy, that means angle y will be greater than angle z. So it's just using the fact that the angles across from it. So if I'm looking at this, it says which corner of the triangle plot of land forms the largest angle? I have to look for the largest side length. So this has the largest side length. So straight across from that side is going to be my largest angle. So angle B is my largest angle. Now that goes both ways. So if I say that angle A is greater than angle B, that means that the side length across from it, so BC, will be greater than AC. And again, you're always looking across the triangle. So it's saying order the sides from shortest to longest. So if I'm doing the shortest side, I have to look at my shortest or my smallest angle. Here's my smallest angle. So across from that, LM is going to be my smallest angle. Remember, I need to make sure to label my side length. Now, if I look at my second largest angle, or smallest angle, I should say, sorry, is 64. So straight across from that would be MN. And my largest angle here would be LN. Now, in order to actually make a triangle, this has to be true. What this is actually saying is that when you add up two of the sides, it always has to be greater than the third side, making sure that it's greater. If it's equal to, that cannot make a triangle. It would either make a triangle that looks like this, where it doesn't actually shut, or else it would make a triangle that looks like this. It gets too far. So if this is not true, then this would be the case if I actually had the lengths given to you. Then can you conclude if these are a triangle? So if I'm looking at this, I want to always look at my, well, actually, I'll test all. So I have to look at 3 plus 7, 3 plus 8, and 7 plus 8, and these three. So I have to see if this, so if I add these together, I get 10, 11, and 15. Is this greater than, because that's what it has to be, greater than my third side? So that's greater than 8. That's true. If we look at this one, that is greater than 7. That's true. And is this greater than 3? 3. That's true. So yes, that would be a triangle. Woo. I want you to try to test this second one by yourself. So again, you're adding two of the sides, seeing if it's greater than the third side. So in this case, these two sides is not greater. It's the same. So that's a false. So this would be no. I technically didn't even have to check the other two, but because I love math so much, I thought, why not? So this last one, it's asking, a triangle has side lengths 4 inches and 7 inches. What is the range of the possible sides? So it's asking for what can x be. So remember, I have to have 4 plus 7 has to be greater than x. I also have 4 plus x has to be greater than 7. And x plus 7 has to be greater than 4. Now, once we do this, we don't actually have to test all three because it's saying what are the actual ranges. So what's the smallest and the largest? So I'm looking at this right here. If I add these two together, that would give us the equation that 11 is greater than x. That's the same thing as x is less than 11. These two are the same. Look at here, I'm opening up to the 11, opening up to the 11. Here, if I'm going to solve for x, I would subtract the 4, and I would get that x is greater than 3. Here, I would subtract the 7, I would get x is greater than negative 3. Well, in this scenario, right here, you cannot have a negative number. So in this case, we're going to X that out because you can't have a side of a triangle be a negative number. So in this case, my range that X is going to be in between would be X has to be greater than 3 and less than 11. So the third side length for this triangle could either be between 3 and 11. Bing, bada, boom. That's all I got for you here, folks. Have a great, grand, wonderful day.